Let me tell you a very interesting fact. It will surprise you to know that the way heat is transferred in solids is not the same how heat is transferred in liquids and gases. Now, why do you think it is so? Because in liquids and gases, the packing of the molecules is not as dense as it is in solids. In liquids, the molecules are sparsely packed, and in gases, they are even more sparsely packed as compared to liquids. So obviously, conduction is not the method by which heat can be transferred from one point to another in case of liquids or gases. So how do you think it is transferred? We shall soon find that out. And you will be interested to learn that it is due to this method of transfer of heat that the climate of coastal regions is influenced. So let us get to the bottom of the mystery and answer all the questions that face us. So now we are going to perform a simple experiment and we are going to show how heat is transferred in water. Here the apparatus considered is very simple. We have taken a flat bottom flask and we have poured a certain amount of water in it. We have also taken a few amounts of potassium permanganate crystals. Now these potassium permanganate crystals are poured into water in such a way so that they don't spread out inside water. They fall to one side at the bottom of the flask. We have also taken a spirit lamp with the help of which we are going to heat this particular flask containing water. Now you will see what happens the moment this particular vessel is heated with the help of this spirit lamp. The reason for using potassium permanganate crystals will soon become clear to you. Now as you can see in this video, the spirit lamp is lighted with the help of a lighter and the heating of the flask begins. Now notice carefully the color of the potassium permanganate crystals. These crystals are concentrated to one side and are mostly at the bottom. Now more and more heating takes place of the flask and you will notice that the color of the potassium permanganate crystals is gradually rising up and reaches the top of the liquid. Now it stays there for a while and immediately afterwards you will find that the color of the liquid again comes down. That is, the color of the potassium permanganate crystals after it had reached the top of the liquid column comes back down to the bottom of the liquid. And at one point of time, the entire water in the flask gets colored by the potassium permanganate crystals. So let us find out what is happening, because I am sure you have a lot of doubts and questions in your mind, and I am here to clear them all out. So let us see what is happening. Firstly, the liquid that was present at the bottom of the flask gained heat energy. How? Because we had placed the spirit lamp at the bottom of the flask, and while the spirit lamp burned, it imparted heat energy to the bottom of the flask. So the moment the bottom of the flask gained heat energy, what do you think happened to the particles present in water? These particles gained the heat energy and started to vibrate to and fro about their mean position more vigorously. In other words, their jiggling increased. So as a result, their temperature increased, and due to this, they started to vibrate with a greater kinetic energy. So the kinetic energy of the liquid molecules increased because of an increase in temperature. So what do you think happened as a result of this? The atoms started to jiggle more. Now, as soon as the atoms started to jiggle more, the liquid started expanding. Why? Because their kinetic energy increased and consequently their speed also increased. So as a result, the particles started moving apart from one another and the liquid at the bottom started expanding. So when it expanded, its volume consequently increased. Now we know that density of any particular body is given by its mass divided by the volume. Density is defined as mass per unit volume. Now, if we keep the mass constant, as we saw in the case of water, In that case, the mass of water was constant because no water was taken out or added. So keeping the mass constant, we saw that the volume increased due to expansion on heating. So what can we say? Since the denominator, that is the volume, is increasing, the density is decreasing. Thus, the density of the liquid that is present at the bottom of the flask decreases. Due to this, it becomes less dense. In other words, it becomes lighter than the liquid which is present at the top and which is cooler than the liquid at the bottom. So as a result of this, the liquid of the bottom rises upwards. And it is due to this reason that the color of the potassium permanganate crystals that was at the bottom initially started rising up as we started heating the flask. So when this happens, the denser liquid that is at the top comes down and settles at the bottom. So you could have seen this in the video when the potassium permanganate crystal color had reached the top of the liquid. Now you must have noticed that immediately after a while, the color started coming down. Why do you think this happened? This happened because the denser liquid which came down was comparatively cold than the hotter liquid which had moved up. So as a result, when this denser liquid came down, it started to absorb more heat energy from the spirit lamp. So in turn, this layer of liquid became more sparse or less dense. So again, this liquid, because it became less dense, it became lighter and started moving up, and the liquid that was already at the top started moving down. This was the reason why you saw that the potassium permanganate crystal color moved down after it had moved up. So this up and down process is repeated over a period of time until the entire column of liquid that is inside the flask gets completely heated up, and you can see that in the video when the entire flask contains the violet colored liquid. That is, the color of the potassium permanganate crystals spreads throughout water. We can understand what is happening with the help of a very simple analogy. Over here, if you look at the animation, you will find that at one end, a person is standing with an excess of books. We compare this person to the heat source. Now, every person who is empty-handed coming in towards this person, we consider that as the liquid. Now, this represents the dense liquid which is present near the heat source. The moment this person takes a book, he becomes less dense, just like the liquid present at the bottom near the heat source becomes less dense on heating. Now the moment this person becomes less dense or acquires a book, he moves to the end of the queue. The person who was previously behind him still empty-handed, and he moves forward, just like the dense liquid from the top settles down after less dense liquid getting heated up has moved upwards. Now this person takes a book and moves back to the end of the queue. This process is repeated for every person who is empty-handed. As you can see, in this back and forth manner, every person in the queue acquires a book from the person having excess of the books. In a similar manner, the complete liquid which we previously considered, after getting heat from the heat source, gets heated up in this manner. The liquid at the bottom gets heated up, becomes less dense, rises to the top, and the more dense liquid at the top settles to the bottom. And in this manner, the entire liquid gets heated up. This process is viable not only for liquids but for gases as well. So we find that in this process, heat is transferred in liquids as well as gases. And this process is termed as convection. So let us see how we define convection. So how can we define convection? Convection is the process of transferring heat from the hot region to the cold region by the actual movement of medium particles. As you saw in the previous case of water, the medium particles actually had to move from the hot region to the cold region in order for the entire medium to get heated up. So as I mentioned previously, this form of heat transfer takes place only in fluids, that is liquids and gases. Now coming back to the original question which I had asked, how do you think this convection process actually influences the climate in coastal regions? Now let us consider the same. In this animation, you will find that air is flowing from land to sea and it is night time. This air that flows from land to sea is known as land breeze. Now let us find out how it is happening and get behind the mechanism of a land breeze. Now during night, the earth radiates heat energy. That is, the earth loses heat. Land is a better absorber of heat than is water, that is the ocean. So land will be a better radiator of heat because it is a better absorber of heat. We have studied that good absorbers are good radiators. So in this case, land will radiate more heat energy as compared to ocean, and the temperature of air above the land will become lower than the temperature of air above the ocean. So on land we have cool air and over ocean we have warm air. Now since the temperature of the air above the ocean is warm, it becomes less dense, expands and starts rising upwards. It moves upwards, as you can see, has been labeled over here, rising warm air. So due to this rising warm air, a partial vacuum is created immediately above the ocean. So in order to fill up this vacuum, air from land rushes in towards the ocean. That is, the cool air from the land moves in towards the ocean to fill up the partial vacuum. This forms what is known as a land breeze. Now the warm air that had risen up from the ocean moves up into the atmosphere where it becomes cold again. So this cold air then again descends and comes onto land, and this entire process is repeated. So this gives us a land breeze where this entire process is repeated through the process of convection. Now consider the scenario which takes place during the morning. In the morning you can see that the direction of the breeze is from the sea, that is the ocean, to the land. Now this is known as a sea breeze. So let us find out during daytime what is the mechanism of sea breeze and why it is taking place. I previously mentioned to you that land is a better absorber of heat than ocean or water. So during the daytime, land will absorb more heat. Land will absorb more heat and the ocean will not absorb as much heat. So the air above the land will be comparatively hotter than the air immediately above the ocean. So what does this mean? This means that the temperature of air above the land surface will be more than the temperature of air above the ocean. So the air above land will expand, become less dense and move upwards, as you can see. So this will create a partial vacuum immediately over land. What this will do is, this will allow the air from the ocean to rush in towards the land. And this is forming what is known as a sea breeze. So this is how a sea breeze is taking place in the morning. Now what do you think happens to the rising warm air? This warm air, once it reaches the top of the atmosphere, becomes cool and starts descending once again. So once this warm air descends, the entire process is repeated once again. And this circulation of air gives rise to what is known as sea breeze in the morning. Both land and sea breeze are the immediate effects of convection in gaseous medium, that is air. So this is how the climate of coastal regions is kept moderate by sea breeze and land breeze. When I say moderate, I mean that the temperature is neither very hot nor very cold thanks to the processes of sea breeze and land breeze. So taking a quick recap, we learned that apart from conduction and radiation, there is another method of heat transfer which takes place primarily in fluids, that is liquids and gases. This is known as convection, where the medium particles actually move from one point to the other, that is from the hot region to the cold region. We demonstrated the process of convection in water column with the help of an experiment which involved water, potassium permanganate crystals, and a burner. We also saw how convection helped us in getting two common phenomena, sea breeze and land breeze. And we also saw how sea breeze and land breeze helped keep the climate of coastal regions moderate.